All right, so let's take a look at our first example where we actually are finding a confidence interval with a mean based on some data. So a researcher for the FAA wants to estimate the average flight time in minutes on a flight from Albuquerque to Dallas. He randomly selects 9 flights and records their times, and you can see them listed there. So first thing, do you think that the population would be normally distributed? Okay, and I think it would be fairly safe to say yes, it probably is going to be fairly normally distributed, mostly because I would say the majority of the flights are maybe within 5 minutes or so of each other, but there may be times that there's a super fast flight, maybe like they have a tailwind or something. There could be some flights that take a little longer because of a headwind or whatever, but again, I would think it's pretty much normally distributed. All right, so part B, find the point estimate for the population mean flight time. So the point estimate, again, is our sample mean. Okay, so based on those 9 numbers, we need to find the average flight time. So we're going to add those values up and divide by 9. And when you do that, you should find that the mean, X bar, is about 103.4 minutes. Okay, that's the average flight time based on the 9 flights that the researcher gathered. All right, if we want to compute the standard error, which goes back to section 6.5, standard error, by the way, is sigma over root n, we would need to know the population standard deviation. Okay, well, it's not probably reasonable to assume we would know sigma because we're probably not looking at every single flight ever flown on American Airlines from Albuquerque to Dallas, Texas. Okay, so it's not reasonable to assume we would have that value. So when we don't know that value, this is when we're going to use that T interval, which is the test that I mentioned back on the previous page whenever it said how are we going to find that margin of error, and I said we're going to go to stat and then arrow over to tests, and then we're going to go down to, again, for me it's number 8, we're going to go down to T interval in order to figure out what's going on. Okay, so go ahead and go to stat and your tests and go down to T interval, which is number 8. Okay, now based on that, again, you can either base this off of data or off of statistics. We have the data, okay? So right now for our input, we're going to choose data because we have actual data, which means, by the way, take a pause and go put your data into L1. So I'm going to go ahead and take a second to do that myself. So remember that stat, edit, and then put your values into L1. There should be 9 of them. Pausing to stick it in myself, which should give you time as well. Okay, once you've got that in, then go back to stat, tests, and T interval. All right, so we're going to use the data. Then it's going to ask us where that data is coming from. And so for me, it's from list 1. You tell it wherever it is you put your list. The frequency we're going to leave at a 1 because we're just using each of those values one time. And then it's asking you for that confidence level, and we want to do a 95% confidence level. So again, 0.95, and then calculate. You will find the X bar happened to pop up right there, 103.44444. And you've got that T interval right at the top. So 97, we're rounding to 1 decimal place here. So 97.2 on the low end and 109.7 on the high end. Okay, what is the margin of error? So again, a few ways you can do that. You can either take that middle value, 103.4, and subtract 97.2 to find out how many minutes you are from the lower boundary. You can take the 109.7 and subtract 103.4 to figure out how far you are from the upper boundary. You can also go ahead and subtract the 109.7. I'm going to go ahead and do it that way. I haven't done it that way for a couple problems. The 109.7 minus the 97.2 and divide by 2, and you will find out that our margin of error is about 6.25 minutes. All right, interpret the meaning of the confidence interval. So we did a 95% confidence interval. So there's let's get all my words in. There's a 95% chance the true mean flight time from Albuquerque, I'm not going to spell that again, from Albuquerque to Dallas is between 97.2 and 109.7 minutes. Okay, now if we do the same thing, but this time for a 90% confidence interval, again, all you need to do is go back into stat, tests, t-interval. Everything stays the same, but change your confidence level to 90%. Now, think about what should happen. If you are going to be less confident that you hit the target, what should happen to your interval? Okay, less confident means the target is getting smaller or the interval is getting smaller. So we're expecting that interval to shrink, okay, not to get bigger. We're expecting that interval to shrink a little bit. And indeed, when I find my confidence interval, it does shrink to 98.4 on the low end and 108.5 on the upper end. Okay, so for interpreting it, the exact same thing we had above. Okay, so see part G, except it's a 90% chance. And then we want to go from 98.4 to 108.5 minutes. Again, just saving a little bit of time, okay? So there's a 90% chance the true mean flight time from Albuquerque to Dallas is between 98.4 to 108.5 minutes. Okay, so what effect does lowering the confidence level, have on the confidence interval? All right, so if the confidence level gets lower, the confidence interval does what? Remember, the confidence interval itself narrows. So we were 95% confident. Now we're 90% confident. We got smaller. Okay, what does that have as an effect on the margin of error? So if your confidence level gets smaller, the margin of error, so remember the margin of error is from your point estimate out to that boundary, okay? We were here at 95%. Now we're coming here to 90%. The margin of error represented again by that really thick arrow I'm drawing. So the margin of error gets smaller. Okay, we're less confident, which means we have a smaller target to hit. The bigger the target, the more confident we are we're going to hit it.